Let's solve logarithms. Lection 14. Okay. Let's go ahead and first convert these to exponential equations. Remember, we would do that. We would do our that what power function, right? So this is log base 10, right? So this is the same thing as saying 10 to the fourth power equals 10,000, right? That's right. And this one is saying that 10 to the 1/2 power equals root 10. And the reason why, remember, if there's not a base here, it means that it's base 10, right? Thought I would redeem myself with that. I can make it worse. Okay. How about this one? This says that 2 to the 8th power is 256. All right, take the base, raise it to what it's equal to. Moving right along, so we can go through this fast, right? 4, that's that 4, to the 4th power is 256. Natural log of 1, that says that e to the, right? Because remember, ln is log base e of whatever, right? Is the same thing as natural log or ln of x. So that means that this is base e, so e to the 0 power equals 1. That's what that says. And this one says that 10 to the 3rd power equals x plus 2. Whoa. Looks like that's the beginning of a way to solve equations. It's a perfect little segue. Into what you're going to do. I like how they say this. Yeah. Here we go. So let's go ahead and get this party started. Log base 6 of x plus 2 plus log base 6 of 3 equals 2. Go ahead and write this on the side of S.99. Okay. First thing I want to do is I want to use my property of logarithms, right? It says that I can put these together, right? That I can write this as log base 6 of 3 times x plus 2 equals 2, okay? So when we're solving these logarithms, we're going to want to have either one logarithm on one side and another logarithm on the other side, or one logarithm on one side and a number on the other side. So we're almost there. I mean, I could actually go ahead and write this as an exponential equation right now if I wanted to, right? But I'm gonna do what's inside my parentheses first. So I'm going to distribute this 3. So I'll get 3x plus 6. Right, so the log base 6 of 3x plus 6 equals 2. And now I'm going to write it as an exponential equation, just like what we were doing before. I'm going to say, hey, this is the same thing as saying 6 squared is equal to 3x plus 6. So, again, this 6 is here. This is the 2, and then the 3x plus 6 is 1. Um, 6 squared is 36. I subtract 6 from both sides, and I get that 30 is equal to 3x. Sorry, let me write that down for y'all. I subtracted 6. Now divide both sides by 30. So x is 10. Yes. I'm dividing both sides by 10. Is it blurry right there? Let's see, the person that made this has the answers there. I can check. Look, I did it right. Yay. I belong here.
You like a math teacher, just like double check what
So let's go through this process again. This is log base 10, right? So let's assume that that's log base 10. But there's nothing written there. So I'm going to write this, first of all, first step. See if there's anything you can condense. Right? If you can write something as a single logarithm. If there's not, then go ahead, then step 2 would be, go ahead and write it as an exponential equation. So I would write this then to say 10 to the 0 power is equal to 3x plus 7, which means that 1 is equal to 3x plus 7. I'll subtract 7 from both sides. I get negative 6 equals 3x. So, dividing both sides by 3, I get that x is negative 3. All right. You know. All right. Y'all remember when we were doing those solving radical equations and solving rational equations, and you had to check your answer because it was possible that you got an answer that didn't work? You got to do that with these. So the problem is that remember in some of your previous exercises, they would give you something like, and I'm just going to write this over here. They would say, hey, so let's say, hey, what is this? Log base 10 of negative 100. We're saying 10 to what power is negative 100? You would think 2, right? Because 10 squared is 100, but it's negative, right? So how do I raise something to an exponent and make it negative? And if you're perplexed, the reason is because there's no way to do it, right? Because this doesn't exist, okay? This doesn't, exist. Except for that there's no way to get around this. This just doesn't exist, okay? There's no way you could raise a positive number to a power and get a negative number as an answer, right? It's just not a thing. You could raise a negative number to some power and get a positive answer, but not the other way around, right? And the other case that exists is, what is log base 10 of 0? Oh. Can you raise anything to a power and get 0? No, there's nothing. I mean, there's no way to do it. Log, you can get 1, right? By raising it to a 0 power, you can get 1, but you can't get this. So this also doesn't exist. So there's a rule then that says that if I have some log base b of x, it has to be the case that x is greater than 0. No matter what. Okay? It can't be 0, and it can't be negative. That's what that says, alright? So that's what we're checking for. Any solution that gives us a log of 0 or a negative number, any number 0 or less, right? It's not a real solution. Okay, it doesn't exist. And we'll have to say that it's an extraneous solution, right? So we'll just mentally check these and make sure that we don't wind up with any extraneous solutions as we go. So, negative 2. If I plug negative 2 in here, I wind up with negative 6, right? Negative 6 plus 7 is positive 1. So it checks, right? It's not 0, and it's not less than 1. And it's not, sorry, negative. Alright. So I can just say, hey, I checked it. I did it. I checked it. I didn't check it. Alright. So let's do the same thing with this one. We're going to write it as an exponential equation. And now we're just going to solve it for x. So 2 to the 4th power, 2 times 2 times 2 times 2 times 2. 16 equals x plus 5. And then I subtract 5 from both sides. And I get that x is 11. Hey, if I plug 11 back here, do I wind up with a number that is 0 or less? Nope. Okay, let me move along. All right. Okay, remember what I said step 1 was? I said step 1, make sure there's only one logarithm on each side, right? Each side can either have a number or a logarithm, but it can't have more than one logarithm. So that means that I got to combine these. I'm going to use my property that tells me that I can write this as the log of the product of my logs, right? So right, again, right? I'm using the property that tells me that if I have log of x plus log of y, that is equal to log of x times y. I guess I should multiply this thing out. We'll FOIL it, right? X times x. It's been a while since you've done this, so we're gonna run you through it real organized, like, right? X times x is x squared. X times 5x is, sorry, x times 5 is 5x. 2 times x is 2x, and 2 times 5 is 10. 1. I'll go ahead and combine like terms, and I get x squared plus 7x plus 10 is equal to 1. And now it's time to write it as an exponential equation. Log base 10, so this says 10. So the first power is equal to x squared plus 7x plus 10, or equals 1. Oh my god, I'm screwing that up. My brain just went to dropping equal signs. Yes.
So this problem's just like that.
No, it's going to be I. So 10 to the first power is 10, right?
Yeah, but you subtract 10 from 1
I like that, though. When I'm solving a quadratic equation, I like to set it equal to 0. Right? And the reason for that is I get two solutions, right? So let's look at it. I'm going to bring this back up here. I'm just going to rewrite the problem over here. Not making any changes except for location. Remember, when you have an equation like this, you set it equal to 0, it's a quadratic, you have an x squared term and an x term. We're going to factor, ooh, that's right, it's been a while since we've done some factoring. But we're going to factor an x out of there. You can see that if I was to distribute this x back in, I will go right back to where I was, right? So they share a common factor of x, and I can take it out. You could subtract x from both, or 7 from both sides, but then you wind up, or 7x from both sides and divide by x, or you're going to miss one of the solutions. Can you do that? Because remember, at this point in time, when you're solving a quadratic, you need to think, hey, what values of x make this true? In other words, what values of x would give me the equation 0 equals 0? -7, clearly, right? That's the first one you usually see. -7, if I put that in here, I have x times 0, right? Because -7 plus 7 is 0 equals 0. True, right? So definitely one of our solutions, because of this one, is that x equals -7. But don't forget, and it's really common for students to forget this, that x gives us a solution too, right? And that solution is x equals 0. Because if I let this one be 0, then the whole thing's going to be 0 too, right? Because 0 times x plus 7 is 0, because 0 times anything is 0. So we have two solutions. We got to check them both, okay? If I plug 0 in here, do I get the log of a negative number? No. If I plug 0 in here, do I get the log of 0 or a negative number? No. So that one checks out. But we got to check this -7. If I plug -7 in here, I do get the log of a negative number, don't I? If I plug -7 in there, if I substitute it back in, I wind up with the log of -5. And that's not real. It's not. There's no such thing. We just told that. We just said that, right? So then this one, boom, not a solution. We're going to point this one out as being extraneous. Yay, and that's what the thing that I didn't cover up says. I wanted to cover all that up. Oops. We don't need to do this discussion because I just did it. All right. Let's solve for x. Okay. So we're going to write this as e to the 15th power, because remember, natural log, or ln, is log base e equals 4x to the 5th power. I'm trying to think if there's a trick. Ooh, can I take the 5th root of both sides? Ooh, I can save myself some time. I could take the 5th root of both sides. Now, it wouldn't be wrong if you went ahead and put e to the 15th in your calculator. Distribute this 4 to the 5th here, and this 4, and write the 5th, so you have 4 to the 5th, and 4 to the 5th here. But it would take a lot more time. So let's not do the thing that takes more time. Let's take the 5th root of both sides, right? Why in the world would I have thought to do that, right? That might be a question you're asking yourself. How am I supposed to know that I'm supposed to do that? Right?
Yes.
Like, okay, great. You do math all day. I don't. Check it out. I saw that this power is divisible by 5, and I saw that also this power was divisible by 5. So I thought to myself, there's a quicker way to do this. And it stuck out to me right away. When I wrote down the problem, I said, ooh, both of those are factors of 5. There might be a trick. And then I remembered. And the reason why this works so nicely is because remember we can write this as a fraction. Remember we can write the 5th root as raising something to the 1/5 power. So then this becomes 4 to the x to the 5th to the 1/5 power, right? And now, a lot of those exponents just went away. I didn't have to do a bunch of crazy calculator work. For instance, I'm going to come up here. If I go 15 times 1/5, what's 15 times 1/5? It's the same thing as dividing 15 by 5. So I get e to the 3rd here. And then 5 times 1/5 is 1, right? So there we go. Nice. Nice. Very nice. I like it very much. In my country of Kazakhstan, I take and divide both sides by 4. Look at that. You are very smarty pants. Look at you and your math skills. Oh. Drop things for fun. This is a game we play in the streets of Kazakhstan. Drop it and pick it up. Look at drop it, pick it up. It's funny, it's a good game. It's almost better than touch rocks together. It's a fun game too. I find the rock, you find the rock, we touch rocks. It's cool. It's an inexpensive game. You can play anywhere. Except for on the boat. Alright, so hey, I can put this in my calculator. I could just leave it like this, right? This is a number. I can put e to the 3rd power divided by 4. It turns out to be a number. But this is a great answer. You can just leave it like that. Why don't we put it in our calculator, see what it is? But this is the most correct answer. All right, so let's put that in our calculator just so we get an idea. What is this number? What is this number? It's going to be an approximation because remember e goes on forever and ever and ever and ever and ever. It's like pi, right? You can't find an end to it. So when I put this in my calculator, I will definitely get an approximation. So I'll use my e key, which is the 2nd ln, and it's to the 4th power, right? Got to make sure to get over there. And it was divided by what? I wasn't paying attention. 4. Oh, well, silly me. So it's going to be approximately 5.021, because we like to round to the thousandth place. 5.02.
They round like more places in like quantum mechanics.
Do they round in more places?
Yeah, like more numbers.
If you're dealing with the very small.
Yeah, like atoms, they round everything. Like how far is too far? You think? Like your quantum mechanics, straight to physics and little atoms.
It depends on what you're dealing with. Particles are very small, so if you're dealing with their weight, you probably need to round to the, I don't know. It's probably going to be a lot. But, all right. I wanted to finish this page in this video, but I don't think it's enough. So let's just go ahead and hit the brakes right there.